Okay, this is the 6-1 to 6-3 review, number 6. It's the free response problem, and calculators are not allowed. And as I read through the problem, I'm going to be finding areas and volumes, and I've got things that are perpendicular to the x-axis, and I see that my y's are already isolated. So based on that, since it doesn't tell me how I'm supposed to find volumes with a revolution, I am going to cut with respect to x because I can see that that's going to help me with part D, and I won't have to isolate x anywhere. So I've made a decision, executive decision, that no matter what they ask me, I'm going to cut vertically and have everything in terms of x. So first thing I want to do is find the area of R, and I've already got the graph drawn for me. So if I cut vertically in the region R, then I'm going to need to label that in terms of x. So the x coordinate is the same. Here on this curve, the y coordinate is always 4. And on this curve, the y coordinate is the region bounded by this curve. So I have a -1/2 times an x plus 4 quantity squared plus 6. So part A, we need to find the area of R. So if we look at R, I guess I should have done that in red, sorry. If we look at R, we're looking at the area of this strip. So the thickness of that strip that we drew was a dx, and the length of that strip was the y minus the y. So it is a -1/2 times an x plus 4 squared plus 6, and then I need to subtract that 4. So that means the area of R will be the accumulation of that height plus the 6 minus the 4 gives me a 2, and then I need to multiply that height times the width, which is dx, and the integral will be from the furthest left x value to the furthest right x value. That's going to be from -6 to -2. So my job is to try and integrate this. It might be easier. Actually, let me see what I did on the answer key. It looks like I did multiply it out. So I'm going to multiply out so that we match up with the rubric that I gave you. That will give me a -1/2 x squared. Then I'll have 8 x's times a -1/2, so that's a -4x. And then I'll have a 16 times a -1/2, that's a -8, plus a 2 gives me a -6. So I'm hoping you can multiply that out. Then we have to answer the question posed by the symbol. What did I take the derivative of with respect to x that gave me this? Well, that'll be move through the constant, cube the x, divide by 3, move through the constant, square the x, divide by 2, minus a 6x, evaluated from -6 to -2. So the first thing I plug in is that -2, so that'll give me a -8 times a -1 is an 8 over a 6. Minus, plug in a -2, that's going to give me a 4 -16 over 2. And then I have minus a 6 times a -2, that's going to give me a +12. And then I'm going to subtract what I get when I plug in -6. So I'm going to simplify this a little bit because I'm going to have a 6 cubed and a 6 on the bottom. So that's really just going to be a 6 squared, which is a 36, minus a 6 squared is a 36. I'll reduce that, so that's a 72. And then I'll add that -6 times -6 is a 36. So that's kind of nice because the 36s and 72s cancel out. So really I'm just looking at this. I have, that's a 4/3 minus an 8 plus a 12. So that's a 4/3 plus a, what is that? 4, that's a 12/3. So I get an area of 16/3. So So now we're ready to move to part B. Part B says I just want to write an expression that gives the area of S. So I'll scroll down in a sec so you can look at that. If I want the area of S, which is this piece right here, we can see, let me use a little pencil here, that this area could be the entire, does S go all the way to -2? So actually it goes all the way down. So this is S right here, and you can see that we could get S if we do the entire region and then subtract out that area of R that we just computed. So we're going to do that. It'll probably be easier than trying to do 3 separate accumulations for S, which you could do, but it's probably not going to be as efficient. So I'm going to come all the way down here. Notice that that top is still going to have the same X and Y. That's a 2. And the bottom this time is going to be X -2. So if I do the entire region, then the area of S is going to be that accumulation. Let's go back and look at the graph here. We're going to be accumulating from -8 all the way to 0. And then we're going to do the length of this red strip, which is this y coordinate minus this y coordinate. So we'll have a -1/2 of that x plus 4 squared plus 6, and then we're going to subtract that bottom y coordinate. Then we'll multiply by the width, and then when we're done we have to subtract the area that we just got in part A. So that's enough. You could leave it just like that and you would get your full points. You don't need to simplify, don't run the risk of making arithmetic errors, just leave it and you're good.